Hello, everybody. So this is my response to the fifth homework. So from the people who submitted the homework, I think most of you did very well. And I think for particular people, I don't have any kind of advice or criticism, but there were some things that some of you struggled with. I mean, we talked about it already during the class, but still seems that for some of you that did not help out. And I think some people did not submit homework, and I think that maybe it was for the kind of the same reason. So let me now go through the homework and give you some idea what was expected of you. So yeah, I think quite a few people, they struggle with this first exercise, which, as I already mentioned, is not really so much of a Python exercise, but it's something that is very, very important. So oftentimes you want to input some data, pictures or actual data about you collected about some events or whatever into the, and you want to use that in your program in the Python. And so what you need is to know the path to your files. So this word path in English, it means like a route or a way. You know, path is, you can think about it, path from a bus stop to school. That's what it's, a path, right? A pathway. And so the same thing is in computer. I mean, in computer, you have your files, you have them stored in different folders, and you have folders inside of folders. I think everybody knows that very well. And so if you want to get to a certain file, you need to know the path to it. So you need to know in which directory it lies there, from basically from the biggest directory. So I'm talking about this from the point of view of a Windows user. If you're Mac user or Linux, I think then you know this quite well. But in Windows, sometimes we get so comfortable that we don't really even need to know this. So if I ask you here, find and store in a variable the path of your information files as a string, files folder as a string. So what, and I gave you, and I gave you here an example, right? So this is the path, for example, to my in my case, right, to my folder. So you see it starts here with, it is a Windows folder. So I mean, it doesn't have to start with the hard drive C. I have it on hard drive C, but if you had D or E, I guess you would have to include it here. But I can start with this. The first one is the users and so on. And so maybe some of you struggle with, how do I find this? Well, there is many ways, and well, this basically is about you being able to use your computer in general. But so for example, in Windows, I mean, you've got this file manager. Personally, I use something else, but this is the standard Windows file manager. And so you see, you can click through the you can click through the folders. Now you see I'm in the folder that contains my information data that I downloaded. It was for the first class. And now if I want the path is, I mean, I could rewrite this, but this is kind of, this is written in a more of a user useful way, but not in a computer useful way. So if I click here, see, it gives me the whole path. So I can copy it. So it starts with, it's a C // and then each folder I get into. So I can copy this. And then I go back. I go back here. And then I just copy paste it. I just copy paste it here. And now there is one thing that you notice, and this is a very important thing. So you see that here, these guys here, we call them the backslashes. So they are oriented like this. They're oriented from left to right. And that's what Windows uses. And if you have a Japanese Windows, if your basic language of your computer is Japanese, then it's not going to be even this. It's going to be the yen sign. Wait a moment, where do I have that on my keyboard? I'm sorry, I don't have that on my keyboard. Well, here. Yeah, but actually, so the thing is that I'm writing the yen sign, but the way it displays it, here is as this backslash, because I have an English Windows. But if you had the, if you have the Japanese Windows and you try to do the backslash, or you're gonna get the, you're gonna see the yens. Oh no, wait, because I have a wrong keyboard. I'm sorry. Yeah, this is the one I mean, right? So you get, instead of the backslashes, you get these guys everywhere. But either way, Python does not like this. Python does not know how to read this, or Python doesn't read this as a path to a folder. So what you have to do is you have to change them into these ones. Okay. So this is the first kind of a struggle that we have, is depending on your system, depending the way you find the path to your folder that you need, to your files, you might get into this kind of struggle. So be ready for that. All right. I guess second thing is, so I ask you to find and store the variable, the path of your information file. So this is this one. And then the second one was of your current working folder. So what's a current working folder? So for every program like Python, I mean, it has some folder that it thinks it works now in. And whenever you store anything, whenever you do any changes, this is where the Python will put the data. So for example, your Python file that you are working on now, like this one, I'm working on this one, on this homework 5 solution copy, the folder I have it in, that's my working folder. And this is important because oftentimes, as you could have seen, so for example, when you use this glob function that has been explained already in the video for this week, if you put here just the star, which means look for any file that has any name, right? The star, we said it can stand for a single character or for as many characters as you want. So if you put it like this, it says look for a string that just contains any character. So it looks for any files names, and it will look in your current working folder, right? So we see that this is useful, and for many functions, we when we ask them to do something, to work with some, to look for some files, or to save files or rewrite files, then they're going to do it automatically, or they will try to automatically do it in the current working folder, right? If you have the data, or if you have your files stored somewhere else, then you have to give them the exact path to them. But that's a bit of a work, right? So oftentimes we just work in the current folder. So that's why it's important to know how to find your current working folder, okay? So if you haven't figured this out for the homework, please take a look at it again. And if you have any questions, if you still don't understand, ask me or the TA. I mean, this is the basic thing that you need to be able to understand, basically, from using the computer. All right. So now that we have this, then we wanted to access the information files. So as we've seen in the description of this week, we can use this glob method or glob function from the glob library. We either give it a specific name of a file using using string, or we give it a path, or, well, because sometimes we either don't know exactly the name of the files, or there are files where parts of the name they're changing, like for our information files, right? They're all called information something. And we want to look at all these somethings. We want to get them, all of them. So we can use this star. So in this case, if you put the star there, it's gonna just look for any kind of thing. And so here I just ask you to use the stored path. So for example, here I have the stored path. And so if you try to use just the stored path, it would just give you the link to the folder. But what we wanted was a path to the files in the folder. So again, I just extend this, right? And I'm looking for any file with any name inside of that folder. So you see, like if I wanted to get into the folder, so I have data, and then here would be slash, and then there would be information1, information2 dot, I don't know, what are these files? What are they? CSVs. Yeah, they're CSVs, right? So the full path to some file would be this slash data slash information01.csv. And I want to look at all of them. So what I'm going to do is I'm going to do data slash and star. And that's why this thing then, it gives me the path to all of the files that are there, to all of the files in that folder, data. And so you see that you could use that, or you could just use the glob with the star. And so you see the difference is that the second one, it gives you just the names of the files in the current working directory. This gives you the whole paths to the in the directory. I mean, since we use the current working directory, they are exactly the same, but here we get just the names, but here we get the whole path. And now it's a question of your application, what you need for in future. So either your names of the files are fine enough, you're gonna just working in the folder, or you want to, have the whole path to them, and that changes. And it depends. And then the second exercise was use the path stored to obtain list of all your files. So we needed all the list of all the files. So we said, okay, give us all the names, and we say them in the file names. All right. So here we used, so because you see this part now, our working folder, it has not only the information data. I mean, I have it there. You might not need to have it there, but I have the information data here. But I have also lots of other files. So now in the second part of the exercise, I wanted the names, I wanted the access to only the information data to the information files. So we have that. No, and then in this third exercise, you should have just plotted the graphs, particular graphs for some of this data. So this is exactly like the exercise that is basically you could have copy pasted and did just some slight change. Basically, the slight change is that you were supposed to choose only 3 out of the 12 data files. So here we see that I chose it using, we have them stored in a list called file names. So from that list, I chose just the third, or it's the 4th, 7th, and 10th entry in that list. And also what I did before, I sorted that list just to make sure. I mean, sure, if I look here, if I call this glob here, you see that they are sorted, right? They go one after another, but they might not be. It's not really 100% guaranteed. So that's why I did use the sort function here to make sure that I knew that I'm choosing the 1, 0, 4, 0, 7, and 10. Yeah. You could have done it also differently, right? You could have you could have just taken these names and called this, create the paths to them. All right. So now we are moving to the second part. And so for today, it was the conditionals. So, and conditionals, usually we put them together with loops. That works very well. So here, just create a list, no problem in that. Then run through the list and print each element of the list. So we see that the list is filled with numbers and with integers and strings, right? That's what the first exercise gives us. The second exercise says, I'll print only the elements of type string. So while I'm going through the loop for element in list, I'm checking if the type of the element is a string, then print it. And then I go back to the loop, right? This is what I do. It's a string, I print that element. And anything else, I'm not asking about anything else, right? It said, if it's a string, just print it, okay? Similarly, if it's an integer, just print the integer, okay? That's very simple. It's a for loop, and inside of it, we have this simple condition. Now I have this list. And now the question was, I wanted to separate, right? So I know that there are strings and there are integers. So I want to separate it into two lists. I want to have lists just of the integers and just of the strings. So I create two empty lists, one for the strings, one for the integers. And then I do a for loop. I go through the list. And then I'm checking if the type is a string, then I add it to the element. I'm sorry, I add it to the string list. Otherwise, because I know that list, in this case, I know that the list contains either strings or integers. So I can use this if else condition, right? Because there is no third choice. There are two choices. Either it's a string or it's an integer. So it's a if you're a string, do this, else you are integer and therefore do something else. So in this case, if you're a string, I put you into the list for strings. Otherwise, I know you're an integer, therefore I add you to the list of integers and just print that. Okay. Now, next is for loops, and there is useful this keyword break. So oftentimes we use looping to go through lists, or from what we call iterable variables. So we're going through something. Let's call it simplified. Let's say through some set of things, through some bag. We're going through one by one. We take a look at each item, and typically, so this is because we're looking for something. We're trying to find something in that bag, and if your goal is to just find something, right, then you want to stop the loop, right? Like you have a bag, you go for a trip, and you're looking for a fresh pair of socks, right? So you're gonna go in and you're gonna look at this. No, this is a t-shirt, this is a sweater, this is a jacket. Oh, socks, and you pick them out and you leave the bag, right? But in Python, if you do for loop, the for loop has to go through completely, right? If I do for element in list, do something, then it's going to do something and then going to go again and in the for loop and so on. So basically, it would be like if you're looking for something, even if you find it, the program would just keep going and looking through every leftover element, and that's not what you want when you're looking, right? Once you find the socks, you want to stop. It's not like you find the socks and you still are looking at what else is in the bag, right? So for this, we are using this break. So you can see that we can put it in different places in the for loop. You need to play with that. You need to place it well. So for example, in this case, for element in list, that's my for loop. So if type of element is string and the length is 4, then the action is break, and break jumps out of the loop and we print it. All right. In next exercise, so here is a kind of a slightly odd, or not odd, it's just a new way of using else. So we've heard about if else, right? So there are two choices, if or else, or you can combine it to get more choices, of course, but you can also combine else with the for loop. And the point here is that if your for loop goes through completely, and in some sense nothing has happened, nothing has, nothing has, the for loop went through completely, that means that probably it didn't do what you wanted. So again, we put this kind of a search example, but there are other examples how to use this, but here, because the easiest one is for searching, right? So for item in wallet, so if item is equal to hyakuen, right, then you would say, okay, I found the hyakuen, and you would break out of the loop, right? Okay, that's very simple. That's very similar like before. But what if I went through the whole loop and I didn't find the hyakuen? So how does the program let me know? So what happens here is that I go through the loop, but this if condition was never called. And so for this is useful, this else. So if the body, if this if condition is never satisfied, if the loop goes completely through, then the next part in the program is going to go for this else, and it will do that. Okay. On the other hand, if the condition is satisfied, I'm going to go break out of the loop, and the program will start after this else here. Okay. All right. So that's also something to play with a little bit, but it can be it's a quite a useful construction. So you see it, the else is not it's not here if else on the same level. The else is on the level of the for loop. Okay, exercise 8, I think it's quite simple. It's just maybe because I used the mathematics, we use the modulus operator, so some people are not so comfortable with, but I think this should be pretty simple. I mean, this is how you started division when you were kids in elementary school, right? We divide one integer by another, and if it's not fully divisible, we just have some leftover, right? So here this tells you, so what this does is this operator, it produces whatever is the extra after the division, right? So if you have, I don't know, 8 divided by 4, then what is left after the division is 0, right? Because 8 is divisible by 4. It's 2 times 4, and so there is nothing extra. But if you have 8 and you want to divide it by 3, so 8 is not divisible by 3, but you can put 3 2 times in it, and there is 2 is an extra. So this would produce the 2. So here is just, so once you know how this operator works, then I think it's pretty simple to write this program. It's just a simple if else. So if what is left after the division is 0, so that means it was divisible. Otherwise, it can be 1, 3, 5 million, doesn't matter. It means it was not divisible. Okay. So you see that basically there's many cases, many outputs of this operator between 0 and the divisor, -1. But basically what it tells us, or how we can perceive it, is whether it just did the full division or there was some extra. All right. Based on this, typical is to talking about prime numbers. I'm sure you've heard about prime numbers, very important numbers in the mathematical theory, and they're behind cryptography and all the safeness of your lives these days, using mobile phones and credit cards and so on. So they're very, very important, but it's also because they are quite they're quite elusive. It's not really so easy to find them all and so on. So here I asked you to write the first code that checks whether a number is a prime number. Well, it's about divisibility, right? A prime number is divisible by itself and 1. So we just check for all the numbers in the range 2 to the number itself, -1, right? And if the number is divisible by any of those, then it's not a prime number. there was some divisor between 1 and the number itself, so it's not a prime, and then we break out of the loop. Or it goes, you check all of them, well, none of them divides them, so therefore it is a prime number. So that's the answer to the first part. And in the second part, you were supposed to check all the numbers between 100 and 200, whether they're prime or not, and also count the number of the prime numbers. So here, basically what I'm doing is I'm doing 2 nested loops. I have a loop of I'm going from the number of 100 to 200. And for each, I'm going to test whether it's a prime. So I'm going to just copy paste this part of the code. Only what I add extra is whenever it's a prime, I also want to add it. I want to count. So this is where I'm going to, so first I'm going to here initiate some counter, and then I'm going to use this, what we introduced also in this lecture, that if you want to, add something, you would just want to increment. If you want to increment your variable, you can write it in this code. Instead of writing primes equals primes plus 1, you can just put the plus before the equality sign, and this just increments the number. And so you see here I have the result, and there is 21 numbers between 100 and 200, which are prime numbers. And finally, this is a combination of all what we did today. So I want to conditionally classify the elements in a list. So I have a list, and I want to classify these. I want to put them in some categories, right? I mean, I look at number 2 and I can think about it. It's a prime number, it's a positive number, it's an even number, right? So it has several properties I'm interested in, not just one, but several. So here I wrote those properties I'm interested in, and what I want to do is I'm going to go through the list, and for each number I want to assign it all the properties that it has, out of the ones I'm interested in. And so of course, very simple way would be just to run through this list several times for each of the property, right? And choose, oh, it has this property or it doesn't have this property. But that's not what I want, because, running through a list more than once, if you do something, that's very costly. Again, we should try to imagine, I mean, we're using computers, but even from computers, if the list is like 1 million items long, it's going to take some time, and their list might be even way, way longer. So ideally, I would want to go through it only once. So that's what I wrote here. So it's just, so the code is here. Your solution might look slightly different, or might look kind of different. It's just a question how to aggregate these. I tried it to kind of like aggregate the conditions. So it's even for these if conditions for checking positivity, evenness, oddness, I tried to do it smart. Maybe, or probably I didn't do it the best way possible either, so I don't check, each separately, because some of these are sort of connected, right? So I, for example, put here that if n is negative or equal to 0, then it cannot be prime number. And then we are just checking for the primes, and then we have a negative or positive, or it has to be 0. If it's neither a negative nor positive, it has to be 0, and so on. Okay. Oh yeah, I'm just looking at this that I didn't for 0, right? The way I wrote the program, the 0, it doesn't check whether it's it doesn't add whether it's even or odd. Suppose 0 is even. Yeah. So I should have changed it here. So how is it? We first give it a prime, not prime. Then we give it a positive, negative. And then so here it's pretty 0, and 0 also is, 0 is even. Yeah, okay. Actually, I want to do this one. Sorry. Plus. No. Okay. I want to, what I want to do here. Okay. Okay. I want to add another category to the list, of course. Not to put two. So I guess the easiest way to do this is I do the append here, and I need to do another append. And here I put even. Right. It's a 0 and it's even because here I have lists of the properties. It's not one string of things, it's a list of strings. All right, so hopefully this helped you, and if still didn't, if you still struggle, feel free to ask during the class time. Okay, see you in the class.